Okay, so we were talking about planning in the real world. That is, we need to take some constraint into consideration. We are talking about the real world. For example, if the plans are going to be too complex, it's better to have hierarchical plans. So you can have a plan at a higher level, and then it can be broken down into plans at the lower level. And secondly, to make it more effective, you need to be able to use things like quantifiers, etc., which makes it much easier to talk about some specific part of your plan. For example, when you're having a space mission or something like that. The third thing is the time constraint. So you may have a limited time to carry out the entire plan, or you may have a limited plan for some parts of the plan. Maybe some machines are available at a particular time, etc. So you need to take that into account. Then lastly, the resources. Resources can be limited. So number of men who are working, number of material that you have may be limited, the expenditure may be limited, you may have a very tight budget on which you need to make the plan. So you have to take all these into account. So the previous plans which we spoke about were basically didn't have all these constraints. They were just simple methods of finding a plan. So one way of going about this is actually to get a plan and then take into account the time and the resources, etc. So what you do is you plan first, you carry out a simple plan and then do the scheduling of that plan. So actions are chosen, etc., in the planning phase, and in the scheduling phase the information about time is added into the plan, and you ensure that the resources and time constraints are met basically. So one example is the job scheduling problem given over here. So what happens here is that these are the jobs that are given to you, and these jobs will have some type of ordering in it. Okay, so add engine 1 has to be done first, and then you have to add the wheel 1, and then you have to inspect. Similarly, you have to add engine 2, add the wheels 2, and inspect 2. So this is the job which needs to be carried out over here, and you have the list of all the resources that are available to you. So you have a engine hoist, you have a wheel station, inspectors, lug nuts, etc. So these are all the resources that you need to carry out this job. And then you have the actions that you can take. So the actions have a duration. So add engine 1 has a duration of 30 units, right? And the resource that it uses. So the resource could be a consumable, or it could be reusable. Okay, so here you use engine hoist, and here you use a consumable which is the lug nuts, right? So this gives you the planning problem in the job scheduling, and what you can do first of all is just get the plan first. Okay, so once you get the plan, you need to see whether the temporal constraints for that is met or not. So here, if this is your start state, these are this will be your plan, and whatever is given below shows you the time that you require to carry out this action basically, and this time which is given on the top is the earliest time and latest time at which you need to do this particular action. So you're assuming that you're starting at 0, 0. That is the start time, earliest time is 0, latest time is 0. And then you have all these actions that take place. So here the action that you have is taking 30 minutes, right? So the difference between if you start at 15, this will be 45 and this take 30 minutes. So this will be appropriately, you will get the values. Now what you do is that you can see that in the bottom level here, the earliest time and latest time is the same, which means you don't have any slack time that is available to you. For example, here you can start anytime between 0 to 15. Okay, so you have 15 units of slack time over here, but the bottom one doesn't. So that is what you call the critical path of your algorithm. And if you look at this bottom figure over here, this bottom figure, this is the timeline. Okay, so in this timeline, you are talking about the various actions that can be taken place and what is the timeline to carry that out, right? And this gives you, so the ordering is also given. So engine 1 is added between 0 and 30, etc. And here if you see, you have the timeline here and you have the various resources that are available here. So for each of these resources, what is the time at which these resources are used, and then this gives you the actions which are taken. So this gives you the complete solution to this job shop scheduling problem. So first thing that you need to do is to get the plan and then do the scheduling. That's the basic thing. So when you come to the scheduling problem, the critical path method is what is used here, which we saw. You find which is the critical path, and according to the time of the critical path, you can set the time for all the other paths which are there in your plan. So this latest time and the earliest time that you have, the difference between that is the slack for an action. The ES and the LS time for all actions constitute a schedule for the problem. So that gives you the schedule for that particular problem, and we can see that if you take two actions A and B and action A comes before action B, then all these will hold. Okay, so the ES earliest time of the start will be 0 and ES of B is equal to maximum ES of A, right, plus duration of A, etc. So these will hold in this case. So the next type of planning that we will see is the hierarchical planning. So this is called the hierarchical task network planning, HTN planning it is called. So here what you have is you have primitive actions and high level actions. So if you look at high level actions, you have what are called refinements, and the refinements will break down the high level action into a series of actions. So high level action can be broken down to give another high level action, or you may get a primitive action. So if you take one high level action and you can break it down into only the primitive actions, it is called the implementation of a HLA, because you have got the lowest level actions which can be immediately carried out, right? So that is why it is called as a implementation of the HLA. So if we look at the HTN planning, what happens is that every first what you do is you just get a plan, right? And once you get a plan, um, you need to see. So for the HTN planning, you start with the top level action or a plan. You have a top level plan and you keep going through that, and at every iteration you find one action which is a high level action and replace it by its refinement. Okay. So once you replace it by its refinement and you keep doing this all the time, right, till you find that you have a plan which consists of the low level actions, then you have reached the end of your planning problem. So you have something like this, okay, refinement. So here we have the refinement go home from SFO, right? So the refinement for that is these steps, okay, drive home from the parking, etc., shuttle, take the shuttle, etc. Refinement go home from SFO, taxi home from SFO, etc. So then you break these whatever action you have down by using what are called the refinements. So this is the hierarchical search. So at every point in time you are finding the HLA, and in using the HLA you are carrying out the refinement here, okay, and you are adding that, appending that on to the plan that you already have. So you are replacing the HLA by its prefix, suffix and whatever plan that you have, okay, the refinement. So that is added on so that you get finally a plan at the lowest level. So it will say things like put a bolt here and a nut here, etc. So that will be the lowest level that you can talk about. Okay, one more type of plan is what is called the contingent plan. So in the contingent plan, you have some things being sensed at the point of time the plan is actually being executed. For example, here you can see you have a table and a chair, right, and you want to paint them. So what is it that you are going to do? What is the color that you are going to use, right? And you also have a can with paint in it, right? So here we have a piece of planning given over here. If color of the table and color of the chair is the same, then you don't do anything. So in other words, you are trying to see that both of them have the same color. But if they don't have the same color, you look at can 1, okay, look at can 2, okay. Those are the two cans of paint that you have. If color of the table and color of can C, then paint the chair, okay. Otherwise, if the color of the chair and the can is the same, then you paint the table. Otherwise, you take can 1 and you paint both table and the chair. So this is just an example of how you can have contingent planning taking place. So this actually happens at the time of the plan. So it will form a plan saying if this is the case then you do this, if this is the case then you do this, etc. So these are what are called the conditional plans. So when you are doing a conditional plan, you need to actually sense something at the time when the plan is being executed. Okay, so you have a sensing action that is taking place. For example, if you look at the spare tire problem, it's also possible that the tire is intact, right? It is not a flat, it's not a flat tire, it just needs to be inflated. So if that is the case, you get a plan like this. If intact tire 1, then you inflate tire 1, otherwise you remove tire 1 and put on the spare, right. So this type of plan is what is known as a conditional plan, and this is done by actually sensing and checking whether the tire is intact or not. And some places it really helps to use the conditional planning. So you can have an action which says action check tire X. Okay, so this will mean some sensing is actually taking place, and the precondition is you have the tire X, and the effect of this is what? To know whether it is intact or not. You will know whether intact tire X is true or false, and then you can use that in your plan that you are carrying out. So another type of planning that we need to see is the replanning. So here what happens is that in the replanning you assume that there is some monitoring of the actions which are taking place. So suppose you need to carry out action, there are some preconditions which need to be met for that action to to take place, right. So what you can do is you can monitor and check whether those preconditions are actually true or not, because there are many things which can go wrong in a plan. So there are three modes of replanning. Okay, in other words, three ways in which execution monitoring is taken place. First one is what is called the action monitoring. Before carrying out an action, you check if its preconditions are satisfied. So every time you need to take an action, are the preconditions for that action satisfied or not? Only if they are satisfied, you carry it out. The second one is that you carry out the plan monitoring, the rest of the plan which is remaining, will it succeed? Okay, you check if the preconditions for all the actions beyond this point are satisfied or not. So that is called the plan monitoring. And the third one is known as the goal monitoring. Before carrying out an action, it checks if there is a better set of goals it could try to achieve. So it keeps checking whether it can find another way of carrying things out in a better way. Okay. So here what we have is that you are going from S to G. So you have a plan which says you have to go to these points to come to G. So now what happens is that because there is some problem here, you find that it does not go from P to E and go this way, but it comes down to O. Okay. So when it comes down to O, it should have gone to E, but it comes down to O. So what does it do? The agent actually replans it, okay, so that there is a minimal repair. So you have to go, you have come to O and you should have been in E. So what you can do is you can just repair the plan so that you go from O to E, and then you carry out the rest of the plan as it is, right. Another way of doing this is just to say that your starting point is O and your ending point is G, and you replan the whole thing again. So you are getting a new plan to go from O to G, and you add that into the plan that you have got up to this point in time. So that's another way of replanning. So only those type of plans where every action has its preconditions given, you can use action monitoring. So when you do replanning, when a plan doesn't work and you do replanning, will it always work? Okay, we can't say that it will always work. For example, if you are in something like a vacuum cleaner agent, maybe the batteries have run out, okay, and whatever replanning you try to do, it will not work, okay. Or if you are trying to paint something, the paint, the can may be empty, and whatever you do whichever can you take, it may not work, right? So it's possible that replanning doesn't work many times, but it could also work. So what are the issues that are addressed by a planner in the real domain? Okay, so you find that nowadays we have very sophisticated planners available. So what those planners do is they plan and then the execution takes place. And at every step in the execution monitoring is carried out, and okay. So what happens is every time there is a problem in the plan, it is replanning takes place and replanning goes on. So you find that all these are happening in real time basically. So it's the planning is itself a very complex thing which is going on over there. And nowadays you have very sophisticated planners which are working very well. They use them for all the space missions, etc. First of all, so let us see these sophisticated planners, what all they are able to do. So agent uses explicit domain descriptions and goals. Okay, so it uses things like quantifiers, etc., makes it clear exactly what needs to be done. And problem decomposition is used to deal with complex domains. Okay, like I said, if you are building a house, you can divide it up into foundations, ground floor, first floor, roof, etc. And then in each of them you can come down to more details. And it can handle domains involving conditional effects, universally quantified objects. And for various subgoals, what can be done is it can store the plans and use them as and when required. And it can deal with errors in domain description by using conditional planning. It can deal with the dynamically changing world. Okay, so whenever the world changes dynamically, it incrementally fixes the plans. Okay, if it detects an error, or if there are some preconditions which are not met, so it takes it and does that. Okay, so the last type of planning I'm going to talk about is multi-agent planning. So in other words, the planning is carried out not by one agent but maybe more than one agent. Okay, so each agent will have their own goals. Okay, and they have to um, solve those goals. Okay, they may and the other agents, either they could help them or they could be a hindrance, or they may not have anything to do with any of the other agents. Maybe each agent has its own job to do. Okay, you also have things like multi-effector planning, where it's like you have multiple effectors only. Okay, so what happens is the same uh, planner or the same agent can have different effects from it, or you can have a multi-body planning. So you have various decoupled agents, okay, which work. When two agents have to coordinate with each other, then you have to see about the coordination also between the agents. For example, if two agents are playing tennis with each other, okay, there needs to be coordination because you need to cover different parts of um, the court that you have, right? So maybe one has to either cover the left of the court and another has to cover the right of the court, or one has to cover the back of the court and the other has to cover the front of the court, etc. So there should be some coordination between agents. So here we have a planner which is given for multi-agent planning. So when you say actors, it means that we are talking about agents. So you have two agents, A and B, which are used over here. Okay. So this gives you the initial state. So A is at the left baseline, B is at the right net, etc. Partner AB and partner BA. So obviously they are playing with each other on the same side. And what is the goal? The goal is to return the ball, and at A right net and at A left net. Okay. So this is the goal that you have, and these are the actions that you can have. So the particular one actor will have to hit the ball, and another action is to go from one place to another place. So these are this gives a multi-agent planning with two actors in it. Okay, you can have more number of actors, and you say that they should be in one of four locations. Okay, so left baseline, right baseline, left net, and right net. So there are four positions in which they can be there, and the ball can be returned only if the player is in the right place. So if the player is not in the right place, then obviously they won't be able to hit the ball into the right place. So this is the multi-agent planning that we are talking about. So this gives a sort of summary of all the planning agents that are there. So now you find that planning agents are very, very sophisticated, and they work very, very well, and they've been used for all this space missions, etc., which are happening nowadays. We'll stop at this point for the planning agents.